Well, hey everybody, welcome to another episode of Master the NEC, where we talk about the National Electrical Code and, of course, all things electrically related. My name's Paul Abernathy, your host as always, and welcome to the podcast. Now, you can listen to our podcasts on many different platforms, and we thank you for all the support that we've been getting for these podcasts. But you can listen to it over on our website, obviously at masterthenec.com. We have a podcast button. You can click there and you can listen to everything right there from your browser and any device that you own. But also, if you're kind of partial to things like Spotify, Deezer, iHeartRadio, iTunes, or any of those type of podcast platforms, all you got to do is search for Master the NEC on there as well. You can take them with you everywhere you go, play them on the job site, play them in the car. You can even send it over to your Alexa device, and you can listen to it while you're in the shower, maybe right before you go to bed, so you can let some of this code stuff sink in. However you want to do it, they're all available. But you also can listen to both our videos or watch our videos and listen to our podcasts over on our YouTube channel, which has a neat app as well that you can get everything there. And in all of our videos and podcasts, we will denote right on the front of it moving forward whether or not it's a podcast or it's an actual video. So that language will be right on the thumbnail so that you know what it is. And so we do obviously a lot more podcasts than we do videos because they take a little bit more time, and I have a lot of information that we like to get out. Plus, I find it is a unique challenge for me to try to convey the message over a podcast, whereas you don't see any pictures. I'm trying to paint you that mental picture. So I find it more challenging for me to do that. So again, but over on our YouTube channel, it's youtube.com/Master the NEC, all one word. And you can get access to all of our podcasts as well as all of our videos as well. And it goes back quite a few years. So there's quite a few episodes there. Just kind of scroll down. A lot of them are still very relevant. A lot of stuff on 2020, a lot of stuff on, very little on 2020 because that's the paid side. So if you click the little join button and you pay $4.99 is the lowest tier, then you can get access to our 2020 analysis. But everything else, we have tons of other content over there on the YouTube channel, going back to 2017, even some back 2014. Just gotta go digging through the archives and you can find it. All right, so today's episode, we're picking up into part 4 of Article 695, dealing with fire pumps. So we're going to get deep into that. And obviously at this point now, we're going to start working into the power wiring. We already covered in part 1, part 2, part 3, all the introduction and things like that. But now we're going to get into the wiring and what needs to be taken into consideration when you're dealing with the supply conductors or the feeders. And we talked about previously what constitutes something that would be supply, whether it's from a service utility or from an on-site power production facility, as well as where you are allowed to make a tap and you create what's called a feeder. And again, you might have subsequent overcurrent protection as well as disconnection means in accordance with 695.4b when you create this feeder. But you're going to have some unique rules that you have to follow for these conductors now, and the protection and, of course, the reliability aspect of it. So that's what we're going to talk about in today's episode. But before we do that, we got to give a shout out to our sponsor, which is Electrician Pride, for you to get all of your good t-shirts and Huggies and coffee mugs and all that with a ton of different logos like Tesla and everything else that we are very original. We don't copy anybody. Everything on there is ours. So again, we'll run that commercial and then we'll get right in to Article 695 and fire pumps. Today's show is sponsored by electricianpride.com, your one-stop shop for electrician-specific t-shirts, hoodies, phone cases, mugs, die-cut stickers, leggings, and so much more. Featuring unique designs for electricians, journeymen, and master electricians, as well as electrical engineers and electrical inspectors. For more information on all the products that are available, visit us at www.electricianpride.com today. All right, so check that out. Help support our podcasts. And again, they take quite a bit of time to do this. I usually do these, and I do a bunch of them at a time, but I usually do them at night and on weekends. So again, trying to make up that. So I appreciate all of the support that you give. All right, so we're going to pick up today at 695.6, which is the power wiring. Okay, so the power circuits and wiring methods shall comply, and again, we're talking fire pumps now, shall comply with the requirements of 695.6A through J, and as permitted in 230.90A, exception number 4, 230.94, exception number 4, 240.13, which incidentally, that is no GFPE on the fire pump system, and on and on and on. So you've got your general rules that we're going to have to meet here in A through J of Section 6 of 695, but just remind you that there are other sections in the code that will make reference to fire pumps and applications, and again, have to meet those requirements. And so just kind of keep that in mind as you're moving forward when you're dealing with the power wiring system. All right, 695.6A deals with supply conductors. So we're talking about the supply to the fire pump, and it could be the supply to the actual controller. Okay, and it says supply conductors, A1, it says services and on-site power production facility. Okay, now remember we talked about this back in part 1. So if you're not familiar with the differences, these are pretty much the on-site power production facility is under the definitions of 695.2, and it differs from on-site generator, for example, is that that's only on when necessary. An on-site power production facility might be a power production facility on a campus, for example, a large complex, maybe industrial, commercial, that actually produces power constantly. That is the power production facility for the campus. Okay, so kind of difference in the two. But what we're talking about here is services, because you could bring a separate service. We covered that as well as on-site power production facility to supply your fire pump. So here's what the code says. It says services conductors and conductors supplied by on-site power production facilities shall be physically routed outside a building and shall be installed as service entrance conductors in accordance with 230.6, 230.9, and parts 3 and 4 of Article 230. So it's going to be treated, you have to route it so that it's considered outside of the building. Okay, that's one of the things that you have to take into consideration, that it's going to be something that is literally outside of the building and meet all those rules for that. And of course, that routed outside is dealing with the 230.6. Of course, the 230.9 is talking about overall clearances like you would have on service conductors, from openings and clearance overhead and all those types. So you still have to meet all those basic rules for these conductors. And the key focus here is they have to be routed outside of the building. Now, then it goes on to say this: where supply conductors cannot be physically routed outside of the building, the conductors shall be permitted to be routed through the building where installed in accordance with 230.6.1 or 2. Okay, so this is very similar to what we would do, again, for services if we can't keep it outside of the building. So we can go look at that and see what we're talking about. But 230.6.1 is simply saying, look, if you install it underneath 2 inches of concrete beneath a building or other structure, then it's really considered outside of the building. Okay, so that's one way to do it. And then, of course, 2 is we're installed within the building or structure in a raceway, but of course you have to encase that raceway in concrete or brick. Okay, so specifically it says brick. So you have to encase it in concrete or brick, and it's not less than 2 inches thick. So it's an encasement allowance here. So I can run it underneath the slab, or I could encase it in 2 inches of concrete. That's how I can treat those conductors if I cannot stay outside of the building. So at least you have some options. First of all, it's telling you can't take it in a building, so it'd have to be underneath the building. And of course, you have a bigger list of allowances underneath the building, just in 230.6. For example, you could go under the building, but you could also be down 18 inches. So there's a bigger list in 230.6. However, if it has to go it can't route outside the building, then it's permitted to route through the building, but you would have to be installed in accordance with 230.6.1 or 2, which is the 2 we just looked at. So again, if you're outside of the building or do something considered outside of the building, You have some rules, but if you're going to have to go through the building or into that space, then you're going to have to follow the rules of 230.6.1 or 2 to make it be considered still outside of a building. Okay. Now, there is an exception to this, and this is saying that the supply conductors within the fire pump room shall not be required to meet 230.6.1 or 2. So they're already in the room. Once you penetrate into the room, and that is highlighted. So it used to be people were very confused with once it pops into the room, do I encase them or what do I do with them as they're coming into the room? Well, if they're already in the room, then they're already in a rated room anyway where the fire pump would be. So again, there's no need to try to meet any other requirement for that. All right. So that is your service and on-site power production facilities. And of course, if you're confused at what the difference is, for example, an on-site power production facility, which is typically not a utility, you need to go back, and this would be a great opportunity for you to pause this one. Just look at what timestamp it is so you can pick up where you left off. I think it's like 11 minutes in. And go back and watch part 1 or part 2. Don't jump in the middle of this because you'll get lost because we're building on things from the previous parts that we've discussed in extreme detail. So we want to make sure that you're not lost as we move forward because then it gets very confusing for you. And also, I am very prone to jumping all over the place. So it's a little easier to follow me if you have the foundation built up to this point. All right, so that's your service and on-site power production facility, supply conductors. Now let's talk about those feeders. And those were the feeders that were permitted on the load side of a disconnect and overcurrent protection that was afforded us in 695.4b. Okay? All right, so, and of course, also this is going to apply to those conductors that are directly connected to an on-site standby generator as well. So from generator, direct connection in, because from a generator, there are always going to be feeders. So this is going to all apply. Okay. So we're dealing with feeders. So let's kind of look at it and see what we're talking about here. All right. It says, and we're at 695.6A2. And if I haven't said by now, and you would know this if you were listening to the other parts, that we're in the 2020 edition of the National Electrical Code at this time. All right. So feeders, it says fire pump supply conductors on the load side of a final disconnecting means. And remember, in 695.4b, it was only allowing you to have one in that application. Right? It was only one. Now, granted, we had some allowances for C to have other disconnects, but the general rule here is, okay, on the load side of that final disconnecting means, we're now going from there out to the fire pump controller, the fire pump equipment, and things like that. So if you designate what you're dealing with right now as a feeder, then these are the rules you have to follow. And here's what it says. Again, we'll read it all entirety so you get it. It says the fire pump supply conductors on the load side of the final disconnection means and overcurrent devices permitted by 295.4b or conductors that connect directly to an on-site standby generator. Remember, that is an option when you have multiple sources. Now, you could have a utility, and if it's not deemed reliable, you could have an on-site generator, okay? Standby generator. And it shall comply with all of the following. Okay, so now when we're dealing with these feeders, again, remember, whether it comes from a generator or it comes from, let's say you tapped on the line side of the service disconnect within an enclosure. And again, remember that tap has to be separate in its own enclosure and designed in a way that it's not going to be taken out by fire. So this was the tap allowance in 695.3A1 that we're talking about. And then it ended up having to hit a disconnect means and overcurrent protection because it was still in the building. So again, if you've determined that your installation requires the disconnection means and overcurrent protection, now you're dealing with the feeders. All right. It says they have to, number one, independent routing. It says the conductors shall be kept entirely independent of all other wiring. Now, this has to do with reliability, and it's not going to get taken out by some other conductors shorting out or somehow. It needs to be run independent by itself, and you run it in your raceway from point A to point B. Okay. Next, number two. It says associated fire pump loads. It says the conductors shall supply only loads that are directly associated with the fire pump system. All right, so a lot of cases, depending on how your install is, it's going to come in, hit that disconnect, and it's going to go straight to the fire pump controller. All right. And number 3, it says protection from physical damage. Okay, so the conductors shall be protected from potential damage by fire, structure failure, or operational accident. Okay, very broad in all those descriptions, all of which physical damage, which doesn't say that, protected from potential damage by fire, structural. Again, you're going to have to determine that based on your routing, where it's at. Again, not running it over the raceways, over other pieces of equipment or something like that could blow up and cause to take it out or something like that. So again, have to meet those requirements. But the next one is the big kicker. Okay, and it's going to dictate a lot, this protection from potential damage. This is going to probably dictate it, and that is once you're inside the building with these feeders, this is where it gets where people tend to say, okay, now it starts to ramp up a little bit. Inside of the building. So remember my example back in part 2, I believe, I can't remember. But I was talking about in Richmond, we had a utility outside. Well, it came and hit over and it hit a disconnect. All right. So again, once it hit the disconnect outside, because they couldn't run these conductors inside, the fire pump was too far in and it couldn't get it routed that way, and they didn't want to encase somebody. So what they did was they put the disconnect. Well, out of that disconnect becomes a feeder. That feeder was designed in accordance with 695.4b. It was sized properly. Well, actually, it was sized wrong originally, but we got it straight and sized right. It's those conductors now that get routed from there. Once they're in the building now, they have to meet some requirements. And we're going to look at it right here. So we're at 695.6A2, and we're at number 4. Inside of the building. We're routed through a building. The conductors shall be protected from fire for 2 hours using one of the following methods. So remember, we're talking about these conductors. These are the feeders. Okay, whether they're coming from a disconnect or they're coming straight from the generator, they have to be protected by one of these methods, 2-hour fire rating. All right, it says number 1, it says a cable or raceway is encased in 2 inches of concrete. Okay, so one of your options is to encase it in concrete. And when we say encasement, we means it's 2 inches all around. It's encased. Okay, so that is one option, and that's basically acting like it's outside of the building, theoretically, but it's basically encased and protected within this concrete. Right? Number 2, within that's A. B says the cable or raceway is a listed fire-resistive cable assembly. Now, that would be under UL 2196. So if the product is listed and evaluated for circuit integrity under UL 2196, then it's going to have a 2-hour rating. Now, let me tell you, you just can't take raceway and throw RHH, RHW in it and say I now have a 2-hour rating. Now, remember, here's where people get really confused. If I took the raceway or cable and I encased it in concrete, then I can use regular conductors on it. I don't have to have anything special when it comes to the conductors. However, if I'm going to use B, which is the cable or raceway with a listed fire-resistant cable assembly, then that means the whole assembly has been evaluated under UL 2196. So in order to meet that higher standard of testing, then it's probably going to have something different when it comes to the conductors inside of it. Okay? Because again, this might be just a plain old cable assembly, might be an MC. It could be a rigid with conductors in it, but it gets tested as an assembly under UL 2196. You just can't go buy conductors and stick them in a cable or stick them in a raceway and say that it's a listed fire-resistant cable system. It says listed, so it has to be evaluated. So it's not something you can just, people call me all the time and say, I want to buy RHH RHW-2 and I want to put it in rigid. Is that a 2-hour rated system to meet this rule? I'm like, no, it's not. Okay, it has to be evaluated as a system. Okay, so that's under UL 2196. Get your copy of that. Again, I remind you that you can get those. Now, UL's documents aren't free. NFPA documents you can see for free, but UL they're not really giving you these documents for free. Okay. So the next thing is C is an option. Now, C says the cable or raceway is a listed electrical circuit protective system. Now, informational note here is important because it says electrical circuit protective systems could include, but are not limited to, thermal barriers or a protective shaft, and are tested in accordance with UL 1724, which is Fire Test for Electrical Circuit Protection Systems. Okay. Again, being that it's required, this system, and it says that it's one of those situations where it has to be listed, then you're going to have to, it's not just an issue, again, of me being able to pull a raceway and put cables in it. Okay. It's not going to work that way. It has to be a listed system, so make it easy for yourself as the electrician, as the designer. Look for something that is UL, or ask for it. Say, if I need this installation, I need it to be UL 1724, or I need it to be UL 2196. And there are manufacturers that make cables. There are manufacturers that make specific types of conductors that, when used with a rigid metal conduit, for example, and it really probably doesn't matter what manufacturer of the rigid, because they're all generally manufactured to a same standard. If you use them together in conjunction, then they will get a listing on it. Okay, but typically they have to test it. Okay, so at the end of the day, these are your options. Now, if you want to get rid of any of that, then just encase it in 2 inches of concrete, and then you don't have to have anything special. Okay, but it's just different things to think about. Now, there is an exception to, the exception is to this entire number 4, and this is exception 695.6A24, and it says the supply conductors located in the electrical equipment room where they originate and in the fire pump room shall not be required to have the minimum 2-hour fire separation of fire resistant rating unless otherwise required by 700.10D4. D, excuse me, not 4D. Now, 700.10, we looked at it earlier. That is one of those situations. Well, I don't know if we actually looked at D, but that's the one. Well, yeah, I think we did. That's fire protection. So that's saying, okay, you don't have to have it in the equipment where it originates, in the equipment room, because of the ratings of the rooms, and the fire pump room because of the ratings. Everywhere else, you've got to have it. But in those rooms, you don't have to have that rating or meet this more stringent requirement. Okay. Now, the interesting thing is, when you think about fire protection, if one of the occupancies that you're doing this in is an assembly occupancy that has not less than 1,000 persons, or it's a building that's being constructed that's above 75 feet in height, or it's educational occupancy with more than 300 occupants, then you're going to kick back into the rules again for those feeders. And under that, you're going to have the need for, again, either automated sprinkling system can negate this need, or you're going to have it, again, a listed electrical circuit protective system with a minimum of 2 hours, or you're going to have to have a cable or raceway that's a listed fire resistant cable assembly with a minimum of 2 hours. Or you can have cable raceway is protected by a listed fire-rated assembly that has a minimum rating of 2 hours and contains only emergency circuits. Again, and of course, you're going to get your all-familiar allowance to use the cable or raceway with a minimum of 2 inches of concrete encasement. So that's what you would have for fire protection under those occupancies. So the rule here is, if what I'm doing is none of those other occupancies that we just covered under, 700.10D, if none of those apply, then I don't have to apply the 2-hour requirement for the equipment room where it originates, the circuits for this fire pump, and the fire pump room. At least those portions I don't have to comply with. Everything from point A to point B would be, but not within those areas. Okay? Now, when it comes to one of these occupancies we just talked about, then that's all kind of, that exception doesn't apply, because 700.10D is going to kick in and say, okay, if it's any of these occupancies and you're dealing with the feeder, then you're going to have to bump it back up, and you would still need to have this type of protection, and you would still need it all the way in the equipment room as well as in the fire pump room if you meet these type of occupancies. Okay, that's generally what it's saying in this overall, review, if you will. All right, now let's move on into talking about some conductor sizing. So we're at 695.6. We kind of learned about the routing and what takes place, and if they're feeders, how I have to route them, protect them, all those things to protect the integrity of this circuit. Now we get to move on to 695.6b, and this is conductor sizing. All right, number one. And I should say, typically the sizing of the actual supply conductors coming to the actual load is all sized, again, based on the load. You already heard us talk about all of the things in the previous editions when we talked about treating the everything for the overcurrent at locked rotor, and then the jockey pump at locked rotor and all that kind of good stuff. So we kind of already covered that aspect of it. All right, so now let's kind of look at this one. So B1, which is conductor size, it says fire pump motors and other equipment. So it says conductors supplying a fire pump motor, pressure maintenance pump, jockey pump, and associated fire pump accessories. Equipment shall have a rating not less than, again, remember, that locked rotor and all that stuff, that was for overcurrent. That was for everything else. Remember, it always had that little exception in it that says, but it doesn't apply to conductors. It doesn't apply to conductors. Now we're going to talk about those conductors. It says, conductors supplying the fire pump motors, pressure maintenance pumps, and associated fire pump accessories equipment shall have a rating not less than 125% of the sum of the fire pump motors and pressure maintenance pumps and full load currents, and 100% of the associated fire pump accessory equipment. Okay? So if you think about it, what we want, and these are motors, by the way, so we want to apply 125% to the fire pump motors, pressure maintenance motors, and the pressure maintenance motors, full load current for those two, right? So that's the fire pump, take the FLC at 125%, take the pressure maintenance motor, 125% FLC, and then we want to take 100% of the associated fire pump accessory equipment. Whatever its value is, you take it at 100%. And so that's our conductor sizing. So that kind of blows. A lot of people seem to have thought that because we're doing the overcurrent, and when there is a disconnect, when we're doing the overcurrent and all that we're doing this at locked rotor, that the conductors have to also be sized for lock rotor, and that's just not the case. They only have to be, they're motors. They're only going to put out so much, right? But since they're continuous loads, then we do those at 125%, but we're only applying that to the pump and the associated pressure maintenance motor, which is referred to as a prime motor or jockey pump, to that. Everything else, even the accessories on that, just at 100%. And we're going to size the conductors accordingly. Now, that's number one. Now, number two says, well, what about if it's a fire pump motor only? And that's all that's being supplied. And these other motors are being supplied from some other circuit. Okay. It's still a motor, by the way. Still has rules in 430. Still have to meet the rules for, typically going to be 125% for motors. But what if it's the fire pump motor only in this application? Now, for conductors. So we're at B2. And this says, conductors supplying only a fire pump motor shall have a minimum ampacity in accordance with 430.22, which is going to ultimately tell you that it's to be taken at 125%, and shall comply with voltage drop requirements of 695.7. Now, this is important because this is there's only two real locations in the National Electrical Code that talk about voltage drop as a requirement. Everywhere else, it's a recommendation, right? Informational note. Back in branch circuits and feeders, and we're designing these things at 3% for the branch, or 3% for the feeder and 2% for the branch, as long as it's not more than a 5% voltage drop overall, performance-wise. But that's not a mandate. Well, here is the first time we are examining a voltage drop requirement. And so it's not something that's optional here. It has to meet the voltage drop requirement. So if you've watched my voltage drop videos, I have an extensive video on voltage drop that I did. It's available over on our YouTube channel. Watch it. because it's the math is no different. It's just the different percentage that you would use, right? So if you're doing voltage drop for a fire pump, we haven't looked at it yet, but we're looking at a voltage drop requirement that is going to be dramatically different when it's starting and running for a fire pump. And we're going to look at that as we get there to 695.7. But the importance here is that you need to know that this is a requirement. This is in a case where it's not optional. Okay, so I'm going to do 125% for this fire pump motor. If that's the only thing it's been, if I'm just doing a fire pump motor, because nothing tells me that I have to do the jockey pump with it. That can be separately supplied. But in this case, if I'm doing the fire pump motor only, follow 430.22, which is going to ultimately be 125% of the FLC. And I have to apply voltage drop to that. Now, you really need to know how to do voltage drop. And so I don't want to rehash that here in a podcast because, again, it's formulas we have to deal with. But you need to go watch that voltage drop video that I have over on our YouTube channel, and it'll become crystal clear. And the only difference here is you're going to have a lot higher percentages than what we use in the voltage drop video because we're talking about fire pumps. And we'll look at that when we get there. All right, so this is what's telling me that I have to apply this. All right? Okay. Let's see. Now, this applies, again, only to the fire pump only. So the conductors that are going to the fire pump motor is what this applies to. So you can have the conductor sizing for fire pump motors and other equipment for conductor sizing. But when it comes to the conductors that are supplying only a fire pump motor, then the minimum ampacity in accordance with 430.22, again, 125%, and you have to apply the voltage drop. I don't apply voltage drop to the jockey pump or the other accessory equipment, only to the fire pump motor does this become a concern, okay, for the motor. All right, next we look at C, which is overload protection. All right, so it says power circuits shall not have automatic protection against overloads. So we do not want there to be protection from overload. Now, we have short circuit and ground fault protection, but we don't have it, and most notably, we're protecting from short circuit only, but we do not want anything to be overload. Okay? Definitely don't want that. So it says, except for protection of transformer primaries provided in 695.5C2, which we've already discussed back in, I believe, part 3 maybe, that we talked about that. And it says, branch circuit and feeder conductors shall be protected against short circuit only. Now, it says, where a tap is made to supply a fire pump, the wiring shall be treated as service conductors in accordance with 230.6, and the applicable distance and size restrictions in 240.4 shall not apply. Okay? So we know that when we tap these, and we had the allowance to tap these back in 695.3a, that if we do this, they are still service conductors. And we have to remember that, okay? So this is only reminding us that, you know what? These are considered taps, all right? They are considered taps when you make that connection. But it goes out of its way to tell you, though, the distance and size restrictions, 10-foot tap rule, 25-foot tap, all those type of restrictions that you see in 240.21, they do not apply to fire pumps. So this is a great example of a modification. Whereas you have something in Chapter 6 that is saying, don't worry about something that was mentioned in Chapter 2. These are fire pumps. We're going to do something a little different. And so that's why it says, hey, this is a tap. There are tap rules. We're very familiar that there are tap rules. These are feeders. Okay? We are very familiar that there's taps. Okay? And at the end of the day, ignore 240.21 and the distance and size restrictions that are listed in that. Okay? This is where you're getting that permission to do that. All right, so this is for overload protection. Of course, then we have some exceptions to those rules. And exception number 1 says conductors between storage batteries and an engine shall not require overcurrent protection or disconnection means. Okay, so straightforward. Any connection between the storage batteries and the engine shall not, typically like between that prime mover, are not going to require overcurrent protection or disconnection means. And number 2, it says for an on-site standby generator rated to produce continuous current in excess of 225% of the full load amps of the fire pump motor, the conductors between the on-site generator and the combination fire pump transfer switch controller or separately mounted transfer switch, because you have the options if you want to do that, shall be installed in accordance with 695.6A2. Okay, so it's just telling you that where you have a generator and it's sized for continuous current, and it's sized so in excess, overly sized, in excess of 225% of the full load amperes of the fire pump motor, then the conductors between the generator and the controller, combination fire pump transfer controller, or if they were separately mounted transfer switch, shall be installed in accordance with 695.6A2. So it's telling you that you can say, okay, I saw what you just read about overload protection, but I need you to go back at 695.6A2 and do it that way, because we're talking about the on-site generator. And that's important because 695.6A2 gives a provision where it's a direct connection between the on-site generator and the fire pump controller. So this is where it says go back to 2. That's where it starts talking about the routing and the loads and the protection from potential damage. And when it comes inside of a building, what you've got to do, whether it's encased or in a listed fire resistance cable. So that's why it makes a reference to that, because it knows that in that scenario, it's still a feeder, but you wouldn't have any overload protection from the actual generator to the controller, for example. And so it's going to force you to make sure that, okay, well, in a protection mentality, you're still going to meet all the requirements of 695.6A2, which again was all the things that we just kind of rattled off about the protection and encased in concrete or whatever. So again, it's just a reminder sending you back for that under that exception. Okay. All right. Now, the next one is, or the last part, it says the protection provided shall be in accordance with the short circuit current rating of the combination fire pump transfer switch controller or separately mounted transfer switch. Okay. So again, this is another example where the SCCR ratings, okay, and you have to make sure that the equipment is in line, again, with all of the ratings on all of the equipment, whether it's overload protection or whatnot. You have to make sure all the ratings are in compliance. Okay. All right. So next, let's move on to the pump wiring. Now we're going to talk about the actual wiring itself. So we've sized everything, right? We're talking about the wiring and what we're doing with this. So this one is 695.6D, pump wiring. It says all wiring from the controllers to the pump motors shall be owned. Incidentally, the reason it says it like that is because if they were one combination unit, then you've got the transfer switch and the controller as one unit. But because it allows you in the code to have a separate transfer switch and then the controller, typically when you're leaving from out to the pumps, it's going to be from the controller. So all wiring from the controllers to the pump motors shall be in rigid metal conduit, RMC if you will, intermediate metal conduit, which is IMC, electrical metallic tubing, EMT, shocks many people, but EMT is fine, liquid tight flexible metal conduit. Hey, how about that? LFMC. Many people don't know that, but that's perfectly acceptable too. Or liquid tight flexible non-metallic conduit. Okay, just a non-metallic product, flexible. Okay, so that's other. Next, it goes on to say listed type MC cable with an impervious covering. So basically PVC jacketed MC, that's impervious covering. It's fine. Or type MI cable, which is basically made up of individual conductors with a copper shielding on it. Nobody does that anymore. Oh, you can if you want, but why would you? If it's going to let me do MC, I'd much rather use PVC jacketed MC or something. I'm certainly not going to go with MI, but that doesn't mean you can. It says right here that you can. It says electrical connections to motor terminal boxes shall be made with a listed means of connection. Okay, makes sense. Twist on twist-on, insulation, piercing type, and soldered wire connections shall not be permitted to be used for this purpose. So again, it's going to be a listed means of termination. Probably more often than not, it's going to be supplied by the manufacturer of the motor in the actual termination box. But this is just saying, you know what? I can't use twist-on wire nuts. I can't use the type that are insulation piercing type. And I can't solder the wire connections. They're not permitted for this application. Now, I can tell you, fire pump applications are very, very specific. The manufacturers that make the pumps, that make the controllers and everything like that, they're not going to give you a junction box on this pump that is not going to have connections in there or give you guidance on the type of connections you need to use. Okay, you just need to know that you can't just bring wires together and use wire nut twist-ons. You can't use insulation piercing type of connectors, and you can't use solder as the means to make this connection. No matter how well you think that would last, it's not going to be permitted for these type of applications. Again, it has to be a listed means of connection. So always seek the manufacturer and say, what do you recommend for these terminations? All right, so the next one we're looking at is E and F. Now, E is just saying that loads supplied by the controllers or transfer switches for these fire pumps can only supply fire pumps loads. Okay, and again, it says it shall not serve loads other than the fire pump for which it was intended. Makes sense. If it's a transfer and a controller for a fire pump, it should only supply that fire pump. So that's just what it says in E. So that's 695.6E. So if you've got a controller and you got a transfer switch, whether they're separate or combined as one, it's only designed to handle the load to which it's to serve, which is obviously that fire pump. Okay, and that's what it's there to serve. Now, F talks about mechanical protection, and this says, look, you have wiring that could be from the engine controllers and the battery compartments. Then they shall be protected against physical damage and installed in accordance with the controller and engine manufacturer's instructions. So again, all of this equipment is going to have instructions. This is just reminding you to follow their instructions because they're going to know best. This is their equipment. So making those connections, definitely want to follow their recommendations. So that again is just making a reference to follow the manufacturer's instructions for that application. G, it says ground fault protection of equipment. It says ground fault protection of equipment shall not be installed in any fire pump power circuit. Now, this is also referenced back in 240.13, which required the GFPE, but in this case, there was an exception or a rule that says that you do not use GFPE for the fire pump circuits. This is a reminder again, do not want that to take place. So no GFPE in the fire pump power circuits. Now, that is also referenced back to NFPA 70, as you see here in the brackets behind it in section 9.1.8.1. So it's not the NEC making up this rule. It's simply saying, look, remember what we're thinking about. We want this thing to trip. Okay, we are not looking. We're here only really to provide the short circuit protection. We're really not worried about ground fault conditions and things like that. That we do not want to have GFPE on this circuit, so just don't do it. Okay. Next is H. H says listed electrical circuit protective systems to controller wiring. Now, this rule is very specific if you're using what's called a listed electrical circuit protective system. Now, remember we talked about that. That was back under the feeders in 695.6A2, and it was one of the options. And that was option C, which it says a cable or raceway is a listed electrical circuit protective system. And that was under UL 1724. So we're assuming that is what your choice was for your circuit to feed it. So now you're going to have some rules. And here's what the rules say. For a listed electrical circuit protective systems to controller wiring, okay, it says electrical circuit protective system installations shall comply with any restrictions provided in the listing of the electrical circuit protective system used. And the following also shall apply. So there's a 1, a 2, and a 3 that if you're going to use a listed electrical circuit protective system, okay, then you're going to have to follow these rules. And there might be rules also within the listing of the UL 1724 that deals with those listed electrical circuit protective systems. So let's kind of look at them. There's 3 of them here. So this is only going to come into play for you if you're using this option for this type of system. It says, number 1, says a junction box shall be installed ahead of the fire pump controller a minimum 12 inches beyond the fire-rated wall or floor bounding the fire zone. Okay, so again, we're talking about a minimum of 12 inches. So we have a junction box. In this system, it's requiring me to install a junction box ahead of the fire pump controller. So I'm supplying the fire pump controller with this listed electrical circuit protective system. That was one of my options. And it says that I have to have a junction box. And it has to be installed a minimum of 12 inches beyond the fire-rated wall. So again, this is obviously installing the fire pump, and the controller has to be inside a fire-rated room. So I'm assuming here that I'm supplying the room, and it penetrates into the room beyond the fire-rated wall or the floor boundary in the fire zone. If it comes up through the floor, then I have to have a minimum of 12 inches beyond. So it has to continue 12 inches past the fire-rated wall or 12 inches past up from the floor boundary of the fire zone, and then I have to have this junction. And again, it's prior to getting to the fire pump controller. I have to have this junction box. Okay. And then number 2, it says, where required by the manufacturer of a listed electrical circuit protective system or by the listing or as required elsewhere in this code, the raceway between the junction box, what we just talked about, and the fire pump controller shall be sealed at the junction box end as required and in accordance with the instructions of the manufacturer. Okay, so the manufacturer is going to tell you whether or not you seal it, or if somewhere else in the code tells you to seal it, then you're going to seal it. Okay, but again, the premise here is the installation of a junction box. If you're using one of these electrical circuit protective systems, if you do, you put the junction box. It's very descriptive on where it has to be. And then you've got the requirement, as required by the manufacturers, they might require you to seal it. Or if somewhere else in the code requires you to seal it, if we haven't gotten there yet, but if somewhere else requires you to seal it, then you seal it. Okay. And number 3, it says standard wiring between the junction box and the controller shall be permitted. So standard wiring means at this point, there's nothing special between the junction box and the actual controller at that point. It just says standard wiring. I'm not so sure I like the word standard wiring, but I would assume standard wiring means it does not have to be listed electrical circuit protective system, okay? Which seems quite odd to me, but I guess, again, a lot of those systems, once you make that connection to the junction box, it's not practical to go beyond that. You're already in the room at that point, to be honest with you. All right, so again, and we know what some of the rules are, but you're already in the room and whatnot, so just kind of roll with it. All right, the next one we're looking at is I. Now, I is dealing with junction boxes, okay? And junction boxes. Now, here's what it says. Now, of course, we saw the requirement for a junction box for a listed electrical circuit protective system to the controller and what rules there for that type of system. Now we're going to look at junction boxes, and we're going to look at them in general now. This is junction boxes in general. It says, where fire pump wiring to or from a fire pump controller is routed through a junction box, the following requirements shall be met. Okay, so it sounds like you're going to let me have junction boxes in this. Okay, I know a lot of designers literally don't want any splices in these circuits at all. So the notion of a junction box would imply that you could have some type of splice. Okay, even though I know engineers don't like it and they feel like it reduces the integrity, it's a weak link and all this stuff. But we got to look at this a little more here. So again, it says where fire pump wiring to or from the fire pump controller is routed through a junction box, the following requirements shall be met. Okay. Number 1, the junction box shall be securely mounted. Well, I guess that goes without saying. It's not going to be floating in the air. It's going to have to be securely mounted to something. Makes sense. I also should remind you that a lot of these are, again, direct extracts from NFPA 20 because of the brackets behind it. So we're not recreating the wheel here with the NEC. I mean, it's pretty much pulling this information from another document. Number 2, mounting and installing of a junction box shall not violate the enclosure type rating of the fire pump controllers. Okay, makes sense. I mean, for me, I'm sitting there going, I got to mount it a certain way, but I can't mount it in a certain way that's going to end up causing a problem to the enclosure, okay, of maybe the fire pump controller. I mean, drilling the side of it or tapping it. Maybe it's a certain rating, and I start doing stuff to it because of how I mount something that could end up. So here's the thing. If you're looking at how you mount it and how you secure it, think about the controller and think about, am I doing it in a way that this controller wasn't designed to have holes drilled in the side of it? It wasn't, maybe I should think of another method of securing it that does not violate the potential enclosure that has its own listing and its own rating just because I want to mount the box. Okay. Things that you got to think about. Be very smart. You don't just say, well, I just slap it on the side of it, and you start drilling it and tapping it and holes and all this stuff, and then you realize that, I might have violated the listing of that fire pump controller. I tell you what, that would be a costly mistake as much as these things cost. All right, so again, it says think about it. Next, it says 3, it says mounting and installing of a junction box shall not violate the integrity of the fire pump controller, because it's kind of same thing in what I read a little bit earlier here, but fire pump controllers, and shall not affect the short circuit current rating of the controller. So I, again, don't want to do anything that would create a problem with that, especially with the equipment. And I can tell you right now, fire pump controllers are expensive. I don't want to do nothing that's going to mess with the integrity of that. Number 4, again, we're talking junction boxes, folks. Number 4, at a minimum, a Type 2. Okay, this is pretty intense now. It says at a minimum, a Type 2 drip-proof enclosure junction box shall be used where installed in the fire pump room. The enclosure shall be listed to match the fire pump controller's enclosure type rating. That's huge. So if you look at the fire pump controller and you look at what its rating is, whatever NEMA type it is or whatever it is, then your junction box is to match it. Easiest thing to say, but at a minimum, it's got to be, at a minimum, it had to be a Type 2. But then it tells you that, but then it goes on to tell you that the enclosure shall be listed to match the fire pump controller's enclosure type rating. Okay? But again, at a minimum, Type 2. So, you really have to think about these things when you're installing them. You just cannot go slap things in. It's important. Next, number 5, it says terminals. It says junction blocks, wire connectors, and splices where used shall be listed. So in this junction box, I could have, a junction box, a block, a tap block, for example, like for lack of a better description, power distribution block or something. I could have something in there. What this is saying is that, yes, I can have connections in there. Yes, I could have splices, but I have to, they got to be listed. Now, when we say listed, I can guarantee you that even just, wire nuts, which is a trademark of Ideal, by the way, they're listed. So very loose here, but it's telling me terminals, junction blocks, wire connectors, and splices, where used, shall be listed. Now, I don't necessarily mean they have to be listed for fire pump application, but they have to be listed for their use as a splicing device. Well, there you go. So I have a lot of engineers who say you can't have, now that's an engineer. They're going to call that out. That's their rule. They don't want any splices. I get it. But the rule allows me to have splices. Interesting. The next one is 6. It says a fire pump controller or fire pump power transfer switch, where provided, again, you can have a combo or separate, shall not be used as a junction box to supply other equipment, including a pressure maintenance jockey pump. So again, supplying this controller and then thinking you're going to tap power out of it, to supply your jockey pump or to supply something out, you're not going to use that controller. You're not going to use that power transfer. You're not going to use that as a junction box. It might look convenient, but you're not going to do it. That is not where you're going to make splices. All right. All right. So again, that is for junction boxes. So now we're going to talk about, end this thing up in this episode, terminations. And it says, we're at J now. It says, where raceways or cables are terminated at a fire pump controller, obviously remember it's coming to the controller now. It says the following requirements shall be met. Number 1, it says the raceway or cable fittings listed and identified for use in wet locations shall be used. All right, so obviously you're in a fire pump room. You might say, well, is this a wet location? Doesn't matter. Doesn't matter. If you're going to make those connections to that fire pump controller in that fire pump controller room, then it's going to be what? Rated for wet location connections. Important. And again, if you look at all the raceways that were allowed to be used, and you saw that it required, if you used MC, it had to be impervious. That's an example where all of those are okay for wet locations. So this only makes sense. So it's forcing you to make sure that if your raceway or cable is coming in, then you want to make sure that you're also going to use a fitting that is listed and identified for use in wet locations. Number 2, it says the type rating of the raceway or cable fitting shall be at least equal to that of the fire pump controller. Okay. I'm not really sure how you would match that, be honest with you. And I would tell most people, if the fire pump controller is obviously going to be a certain type rating, you don't use the same rating for raceways and cables. But just make sure that when we say type, that we're talking about, make sure that it's for wet location, make sure the fittings are wet location. If it requires it to be a certain rating, like the 2-hour rating for this feeder or something like that, just make sure it has that 2-hour rating, make sure it has all that other stuff, and that's about all you can do with that one. Number 3, it says the installation instructions of the manufacturer of the fire pump controller shall be followed. So whatever the fire pump controller manufacturer tells you to do, for example, they might tell you the only location that you can bring in your cables or your raceways. And you have to follow that, whether it's underneath or there's a specific location on the side that they designate for it. You're going to follow that. And that's what you have to follow. That's what they tell you to do. Now, the next one is the one where I used to see the biggest issue with. And the last one on that one is number 4, and that is alterations. Check this out. It says, alterations to the fire pump controller, other than raceways or cable terminations, as allowed elsewhere in the code, shall be approved by the authority having jurisdictions. Now, this means that other than locations or specific allowances for you to be able to get that raceway or that cable into that controller, that if there is other alterations, I should say, as you know, have to be approved by the AHJ before you can do anything. So any alteration to the fire pump controller, again, other than raceway or cable terminations, which again, you're going to alter it because you got to knock them out. You got to punch holes. Anything else, it needs to be approved by the AHJ. All right. So be aware of that. And remember, again, we're not going to reinvestigate the internal wiring. We're not going to be trying to second guess the fire pump control designer. Inspectors, don't try to second guess them. Let them do their job. We don't need to go beyond it. Let's worry more about the supply conductors to it. Let's worry about the feeder conductors to it. Let's worry about the conductors and sizing to the fire pumps and things like that. Let's not reinvent the wheel inside of the equipment, okay? And alterations to a fire pump controller, there should be absolutely none except for the locations where raceways or cables come in to the actual piece of equipment. Okay. And there's going to be, I'm telling you, there's going to be designated areas where that needs to come in because there's a lot of electronic components in there. And so we just have to be real careful in how we enter these fire pump controllers. Just follow the manufacturer's instructions. Okay. All right. So that's all we're going to talk about in this episode. Next episode, we'll pick up from here with 695.7 voltage drop, a little more discussion, and then we'll get into a little bit more information on fire pumps. Other than that, but we're almost done. So again, thank you for listening to here to part 4. Stay tuned for part 5, which I'm hoping will be our final episode of this. And again, if you want to find out more about the courses that we offer at Electrical Code Academy, visit our website at masterthenec.com, and you have a courses link button at the top, or they're also along the left side of the website. You'll see that we offer commercial, residential, industrial, grounding and bonding, and NEC code under the Fast Tracks program, so you can learn the NEC a little bit better. We have all those. We even have Electricity 101 course. All of these are also available over at the Electricians Academy, and that is electricalinstructor.com. Or again, you can see them all at masterthenec.com. So hopefully you'll check those out. If you have any questions, feel free to email us at info at masterthenec.com. I'm more than happy to answer your questions. Visit us over on all of our social media. Usually it's all at Master the NEC. And Facebook, check us out at Master the NEC Forum. If you're preparing for an exam, look for Master the NEC Exam Prep. We'd love to see you in there. Till next time, stay safe. God bless.